Alright, and it's time for section 3.3, Dividing Polynomials with me, Mr. Hain. So let's do a quick review of long division of polynomials. So if we're looking at a problem that looks something like this, we're dividing x squared plus 14x plus 45 by x plus 9. It's kind of like factoring but by long division. So my goal here is actually going to try to multiply x plus 9 and just the first term, this x, so that it matches up with this x squared. So x times x is equal to x squared, and x times 9 is equal to 9x. This is how I get the green line here. Now you see this blue subtraction symbol. I'm actually going to be distributing that subtraction symbol. So x squared minus x squared is going to be 0. And 14 minus 9x is going to be 5x. So 14x minus 9x is 5x. And I'm just bringing down the 45. And again, I'm just looking to see what matches up, or what I would multiply times x to match up with 5x. And of course, that's 5. So 5 times x is 5x. And 5 times 9 is 45. And here I just have, in the same color, I'm subtracting, so that again distributes the negative. So I have 5x minus 5x and 45 minus 45. This positive 45 comes from 5 times 9, but it's not positive while I'm subtracting. I'm subtracting the entire amount, or I'm distributing the negative. So x plus 5 is the answer when I divide x squared plus 14x plus 45 by x plus 9. Awesome, let's look at a more complicated example. And again, remember here, all I'm really trying to do is match up a number or a term that I can multiply this by, which is x, to get 2x to the third power. So x times 2x squared will match up and give me 2x to the third power. And 2x squared times negative 3 is going to give me negative 6x squared. And of course, I subtract these, so this becomes addition. And it's going to become 3x squared. So 3x squared plus 6x squared is going to give me the 3x squared here. Again, it changes the sign when I distribute the negative. And I'm going to see what multiplies by x to get 3x squared. And of course, that is 3x. So I multiply it out, and I have 3x times x is going to give me 3x squared. And 3x times negative 3 is going to give me a negative 9x. I distribute the negatives, and of course, that leaves me with negative 2, because negative 11x plus 9x is going to get me negative 2. Remember, distribute that negative. Can't say it enough. So once I've done this, I just bring down the 7. And again, I want to ask myself, what can I multiply times x to get negative 2x? Of course, that is negative 2. So negative 2 times these gets me negative 2x plus 6. And when I subtract, again, distributing the negative, 7 minus 6 is 1. Now this is different than my first example because I actually have a remainder. So when I have that remainder, I take the quotient, which is 2x squared plus 3x minus 2, and I'm going to add the remainder divided by my divisor. All right, so that's how my answer in the box is 2x squared plus 3x minus 2 plus 1, which was my remainder here, over my divisor, which was x minus 3. Excellent. Again, this is just a review. We're not going to be long dividing by polynomials. We're really just going to be using synthetic division. So let's take a look at checkpoint 4. This is a quick review. There is an example of this in your textbook, and it goes into depth and detail, but I'm going to be looking at this one right here. So if I'm dividing by x plus 2, remember for synthetic division I can't have any coefficient of x, and it must be plus or minus a real number. So I'm taking the opposite sign, so this is plus 2, I have minus 2. It's the 0 of this binomial. And these numbers here come from the coefficients of my dividend, which is what I'm dividing. So the coefficient of x to the third power is 1, and there is no x to the second power here. Notice that it's missing. There is nothing to raise to the x to the second power, so that's why I have this 0. And once I have this 0, I can go back through and I can continue going. Negative 7 is the term for x to the first power, and then negative 6 is the coefficient or the constant term. And I'm going to add this line and bring down the 1, which is just, I just bring down the first coefficient. And now I'm going to be multiplying and adding. So negative 2 times 1 is going to give me the negative 2. So again, the negative 2 times this 1 gave me the negative 2. And now I just add downwards. And when I add downwards, 0 minus 2, of course, is negative 2. And again, I'm going to multiply. So negative 2 times negative 2 is going to give me positive 4. And negative 7 plus 4, negative 3. I multiply the negative 2 and the negative 3 together. That gives me positive 6. And I add these, and a negative 6 plus a positive 6, of course, is 0. So I have no remainder. So what these numbers are, the 1, the negative 2, and the negative 3, are actually coefficients. So since I divided by a linear term of x, I'm actually just going to subtract. So this exponent was a 3, so now it just becomes 1 less, which is x squared. And these numbers here are the coefficients of my quadratic function here, down here. So the coefficient of x squared is a 1, the coefficient of x is negative 2, and the coefficient of negative 3, of course the constant term now, is just negative 3. So this means that if I were to multiply these two together, x plus 2 and x squared minus 2x minus 3, I would have my original dividend, which is x cubed minus 7x minus 6. Awesome. So synthetic division, super powerful way of shortcutting what we saw in long division of polynomials. Now, here's the deal though. How can we use this? When am I ever going to use this? So you might have seen me do this on a study guide previously, but I love using synthetic division specifically for the remainder theorem. So the remainder theorem states if a polynomial function is divided by x minus c, then the remainder is the value at f of c. All right, so let's get an idea of what this looks like, and then I'm going to revisit the remainder theorem. So given I have this long function, a cubic function, I want to find the f of 2. Now, up until this time in your mathematical education, most likely what you've done is you've just substituted in the 2. So where you have this 2, you're going to put the 2 in for the x cubed, the 2 in for the x squared, the 2 in for the 5. You're going to raise and put everything into your calculator, or you can do it by hand even. However, synthetic division offers us a very quick way of doing the exact same operation, sometimes even faster than entering everything into your calculator, especially for longer functions. So, since I want to find the f of 2, 2 is what I'm synthetically dividing with. And again, the 1, negative 2, 5, and negative 17 are the coefficients of my x terms of my function. So here I'm going to just bring them down, and I'm going to simplify. I have all the work shown, but bring down the 1. 2 times 1 is 2. I add these, I get 0. 2 times 0 is 0. 5 plus 0 is 5. I'll multiply again, so 2 times 5 is 10. Negative 17 plus 10 is negative 7. Now, the remainder theorem says my remainder is that value of the function. So without plugging anything into my calculator, and by only adding, subtracting, and multiplying, I know that the f of 2 for this long function, the f of 2 is equal to negative 7. You might want to pause the video now and just type everything into your calculator, or even into Google, and see what that value of the function is. Excellent. So let's go to a quick and dirty example for another remainder theorem. So checkpoint 5, given that f of x is equal to 3x cubed plus 4x squared minus 5x plus 3. We want to find the f of 4, so the value of that long function if I were to plug in negative 4 using the remainder theorem. Set it up. I have a negative 4, I have the third power, the second power, the first power, and the 0 power of x. So these line up and are already in order. You have to make sure they're in order. Bring down that 3. And now I'm going to multiply negative 4 times 3 is negative 12. Add them down, so I get negative 8. I have negative 4 times negative 8 is positive 32. So 32 minus 5 is 27. Now these numbers getting large. But negative 4 times 27, of course, is negative 108. And if I were to negative 108 plus 3 is a negative 105. So simply that just means that the f of negative 4 is negative 105. And while I might have used my calculator to multiply negative 4 times 27, I don't know my 27's timetables, I do know that this is probably quicker than me typing all of the coefficients and everything into a calculator. Either way, the remainder theorem is a tool that we can use to evaluate functions of values of polynomials quickly. All right, so let's take a look at the factor theorem. So we're going to let the f of x be a polynomial, and if the f of c is equal to 0, then x minus c is a factor of the function. And the same thing, the converse holds true. If x minus c is a factor of the function, then the f of c is equal to 0. So how we're going to use this? See, we're going to apply the factor theorem by solving 15x cubed plus 14x squared minus 3x minus 2 is equal to 0. Given that negative 1 is 0 of that function. So is it, again, using the synthetic division? I know because the problem tells me that negative 1 is a 0. I can synthetically divide, and the remainder should be 0. So let's start by bringing down the 15, negative 1 times 15, and then add them up. So I'm negative 15 plus 14 is negative 1. Multiply the negative 1's together and add down. I get negative 3 plus 1 is equal to negative 2. And I can already see negative 1 times negative 2 is 2, and so my remainder is 0. So this definitely checks. If I had gotten something else, I'd want to recheck my multiplication and addition. But the powerful thing is here, these are again coefficients of now a quadratic expression. And I can factor this expression using the Xbox method. So 15 times negative 2 is negative 30, how I get the number on the top. Negative 1 is the coefficient for b. So now I'm looking for the numbers that multiply to negative 30 but add up to negative 1. And of course, those are 5 and negative 6. So this leads me to the box. So the 15x squared comes, of course, from the first term. This green negative 2, of course, comes from my original quadratic. And the 5 and the negative 6 are the coefficients of x. So now I'm going to factor. And I want to see that when I factor in the column, 15x squared and negative 6x share a 3x as a factor. The only thing shared by 5x and negative 2 is 1. There's no terms or factors that they share at all. Now going by row, I see that I have the 15x squared and the 5x share a 5x, and the negative 6x and the negative 2, if you factor out the negative 2, that's the only term that they have in common. And of course, the row and the column, these now become the binomial that will multiply to 15x squared minus x minus 2. Using the zero product rule, I know that the x value that I would plug into the first binomial would be 2/5, and that would get me 0. It's by isolating x. And in the second one, using the zero product rule, I see that by the fraction would be negative 1/3 that I plug in here to 3x plus 1, that binomial term, would get me 0. So now I've actually solved for all of the zeros of this large function given that negative 1 is a 0 of it. So it's kind of a way for me to shortcut directly to a quadratic formula or a quadratic expression for me to factor that. Again, factoring is paramount and key. Go ahead and practice those and practice factoring. And that gets me my 3 solutions for my function, or the 3 zeros, which are negative 1, negative 1/3, and 2/5. And that was dividing polynomials. This is a quick and easy, straightforward section, but we're going to be doing heavy lifting with synthetic division from here on out. So please make sure that you understand how to do this, and I will catch you next time.